Hello, ladies and gents, Dr. Skinner here. Um, Now moving on to designing distributed internet systems. This is chapter 12A. Our learning objectives for today. What are we going to talk about? File server and client server environments, alternative designs for distributed systems and their trade-offs, and cloud computing and other trends that help organizations address infrastructure related challenges. So here we are in the very last stages of design. So we've got today and another class where we're going to be looking at the last bit about distributed internet systems. Let's begin by looking at the design process within distributed and internet systems. You might think that there are some standard rules for the design process. Well, actually, there is no specific technique. You know, there are guidelines, but no one generally accepted guideline exists. Okay, so remember, we're not talking about single location, we're talking about multi-location, distributed. As a result of our environment being distributed, there are other factors that we need to take into consideration. Okay, so there are different issues to a single location, but multi-design is more challenging with extra steps to consider. So what are we thinking about? What are we concerned about? Well, you can see here, we've got more moving parts. We've got more components that make up our environment. With more components, there's a greater risk for things to go wrong. And as the greater things of risk to go wrong, we need to do more to ensure that they all stay right, if that makes sense. If things do go wrong, you can see the list down there at the bottom where we are going to be concerned about. We're concerned with reliability, availability, survivability, and performance. Okay, so as a result of going through this design process, our output is going to be this document that consolidates all of our system design information. Okay, so for each site in our environment, because remember, it's not just a single location, we're doing a multi-location, that's what distributed means. We're going to have descriptions for each site. We're also going to talk about how much data is being used in each site, by whom, what business processes are being used in each environment. And we're also going to provide alternative architectures depending on the needs from a site data or processing perspective for each location as well. So what might the deliverable, the distributed and internet system guidelines look like? It looks like this. Okay, so we're going to have a description for each site, where it is, physical location, as much information about the infrastructure as you could possibly provide, details of the personnel, and so on and so forth. We're going to be talking about the data usage, the elements used, created, updated, and deleted, what processes are used by the business when interacting with our information systems, and the pros and cons of no technological support, non-network local systems, various distributed configurations, and so on and so forth. So when we have this document, these are all the things that we need to consider, all the types of information that we need to consider when implementing a system. We'll talk about some of these a little bit later on. So let's take a step back. Let's go back to basics. Let's talk about some of the things which I'm sure majority of you already know about, but we never take anything for granted in this class. So let's go to basics and talk about networks and take it from there. So we're talking about, majoritively of the time, local area networks or LANs, and you've probably heard that term. So what does it say? Cabling, hardware, and software used to connect workstations, computers, and file servers located in a confined geographical area. Okay, so typically located in one environment. This could be a campus, it could be a building, and so on and so forth. Now, in these LAN distributed systems, you're either going to see a file server architecture or a client server architecture. Let's look at both of these in turn. So what do we mean by a file server environment? So a file server environment, let's read it. A device that manages file operations and is shared by each client PC attached to a LAN. So it acts as an additional hard disk for each client PC in a file server architecture. So next time you open up your Windows or your Mac and you're looking at what disks you've got mounted locally, you may have disks which appear to be mounted locally, but which are actually being shared by a client environment. Okay, so your PC might recognize a logical F drive, which is actually, wrong way, Richard, which is actually a logical, which is actually a disk volume stored on a file server on the LAN, okay? So a file server is a shared storage device and an extension of a typical PC. So here we can see a file server model, an example. So we have 3 clients. So we have our local area network. So we have our file saver, which kind of provides our context for access to our data. So a client requests data. The thing about clients and file servers requesting for data is that when they do a request of data, they have to have the entire data sent back to the client. Okay, so um, you all the data manipulation and querying and so on and so forth is actually performed on the PCs. So request for data, request to lock the data, the entire file of data is sent back, everything's locked, and then you do what you do, and then you send it back. So is it the most effective? Is it most efficient? No, I would say not. You've got a lot of data movement going backwards and forwards between your file server and your client all the time. And the context of that is that therefore your network capacity needs to be greater to handle all that data transfer, okay? So there are limitations. Let's look at some of these in terms. So to my point, excessive lots of data movement. Entire database must be transferred instead of individual records. As a result, you also need to have powerful client workstations, okay? So you've got to have the capacity to do all your computations and queries and maintenance and whatever it is locally, because you're going to have a copy of the database management system, which is going to be stored in your file server. That's actually going to be stored on your local client as well. So any data manipulation is going to be performed on the PC and then sent back to the database management system on the client, on the file server. So when a client queries some data, the whole product table is being queried, is transferred and scanned at the PC. The desired records are found. Whatever is done, and then it's all sent back to the file server. So what does that mean? Well, it does mean, as you can see in that last point, we have this concept of decentralized data control. Okay, we have a database management system, a copy of our database management system at each of the workstations. Okay, that being the case, there has to be a very complicated level, or probably more complicated level of, data control than we would see perhaps in a client server architecture, which we'll look at very, very shortly. So lots of data means we need to have a more powerful network capacity, you know what I mean, than we would do otherwise. We need to have more powerful client workstations to look at managing all our data manipulation locally, and it means that our control of our data is decentralized. So we can have concurrent control, recovery, and security, which is all very, very complicated. We're locking data at each workstation, at each PC. Application pages have to be very, very sophisticated. It's complicated. An alternative to kind of the file server environment and a way to address the limitations is the client server architecture. Okay, what does it say? A LAN-based computing environment with a central database server and application programs on each client. Okay, so application processing is actually divided between client and server. The client manages the user interface, the database server is responsible for data storage and query processing. So what are the component parts that make up our client server environment? Well, we have this database engine at the back end. The back end portion of the client server database engine, which runs on the server, gives all the database processing. So we note that the processing of the database, it takes place on the server, and is not going on the local client workstation. Okay, the client is the front end portion that provides the user interface and the data manipulation functions. Okay, we also have backend functions where the central database server engine performs all the commands sent to it, and then the front-end applications, which is the user interface functions. The next page, this is basically the difference between a LAN file server and a LAN client server architecture. Okay, when a client on a file server architecture requests for data, the entire file has to be sent to the client. This means that data has to be locked on the server. There's a lot of data going across the network, and control is decentralized. If I do the same request on a client server architecture, the client still requests for data, but now only the result of the request is sent back to the client. All the data processing is performed on the server. It means that our network capacity can be less. That means our control is not so decentralized. It means that the security is less difficult, less challenging to implement, because we're not having so much data being transferred across the environment. As a result, you can see, ladies and gents, that the client server architecture is exponentially more efficient. So this table 12.1 kind of summarizes the differences between the file server and client server architecture. If we look at these 6 different characteristics of processing, concurrent data access, network usage, database security integrity, software maintenance, and hardware and system software flexibility, you can see that there is some fundamental difference. So processing for a file server, all done at the client. For the client server, it's done at both the client and the server. Concurrent data access is done by the client for the file server, and for the client server, it's managed by the server. Network usage for a file server, large file and data transfers. Client server, efficient data transfers. That's probably one of the biggest bonuses, as well as security. Database security and integrity, good segue there, Richard. File server, low, managed by each client, so low security. Client server, high, managed by the server. Maintenance from a software perspective, it's low on a file server. Software changes just on the server. Client server, a little bit more complicated because you have component parts being changed on the front end, which are located on the client. And then hardware and system software flexibility. Client and server decoupled and can be mixed, but for a client server, you need more coordination between the client and the server because you have the front end and the back end in different locations. So the overall advantages of the client server, right? First one, it leverages technology, more computer power for low cost. Today's workstations deliver impressive computing power at a fraction of the cost of a mainframe. So you can use what we call a normal client workstation, and you can get really excellent, outstanding performance. Your processing is done to where the data is stored, so it's going to be faster. Right, it's going to be faster to respond, faster to access, less network traffic, less cost for your networks, and so on and so forth. Facilitates the use of graphical user interfaces and visual presentation techniques, and it encourages the acceptance of open systems. Okay, so now let's talk about the distribution of information system functions, because this is kind of what's tied into what we're talking about from an application perspective. So application system functions can be distributed between clients and servers in different ways. So client-server architectures represent the way that different application systems functions can be distributed, right? There are several variations which are based on these 3 functions of an information system: data management, data presentation, and data analysis. Okay, so these are very important to note. So the functions of information system: data management, data presentation, and data analysis. God, it's been a long day. Okay, so what do we mean by data management? We're managing the interaction between software and files and databases. Presentation, managing the interface between the users, us, and our software. We talked about forms and reports. And then data analysis, transforming inputs into outputs. Okay, so the client-server architectures distribute the functions of the client and or server. What we're basically doing is all these different functions of data management, data presentation, and data analysis. We can do this load balancing between clients and servers, okay? But there are different ways to partition these functions in a client-server environment. Okay, so the way we balance our data management needs, our data presentation needs, and our data analysis needs between our clients and the service can be done in different ways. Okay, so for one thing we see, and you've probably come across these, we can have application servers. Okay, so we have an application server where data analysis functions primarily reside, which you connect to. We can have virtual machines, which is this software emulation of a physical computer system. More efficient sharing of physical hardware resources. We can create virtual versions of many different parts of a computer environment, hardware platforms, operating systems, and so on and so forth. And then we can have this three-tiered client-server environment. And this is an environment which, if you've done the database class, you will absolutely get this straight away. This is kind of, we talk about data management, data presentation, and analysis. And this is the environment where these are developed and maintained in a separate modules that often reside on these separate physical or virtual machines. And this is what it might look like. So you might have this presentation tier, logical tier, and data tier. Okay, and this is the equivalent of a database schema, actually. The top tier, the presentation tier, the topmost level of the application, which is the user interface. Okay, we have the logical tier, which coordinates the application, the commands, makes the logical decisions and evaluations, and performs calculations, moves, kind of joins our presentation tier to our data tier. So here, information is stored and retrieved from a database or file system. The information is then passed back to the logical tier for processing, and then back to the user. Another component part that we need to know about in this environment is something called middleware. So we've got hardware, we've got software, we have this term called middleware. So what does it say there on the left? What do we mean by middleware? This is a combination of hardware, software, and communication technologies that bring all the management, presentation, and analysis together in our client server environment. The easiest way to think about a middleware, I always think, is it's like plumbing in a house. In your house, you don't see plumbing, right? You see the water that fills your glass when you turn on your tap or faucet. Okay, the way the water gets to you as the end user is the same way the information gets to your device. It's by middleware. So water to you via plumbing, information to you via middleware. Okay, so it's kind of like this unseen, taken for granted kind of mixture of hardware and software and comm technologies that facilitates our interaction between users' visual representation of data and where it's come from. Okay, so that's the kind of the broad concept. What else do we have? We have APIs, application program interfaces. And these are the software building blocks that are used to ensure that common system capabilities in the modules are standardized to facilitate data exchange between different clients and servers. So they can be used on any kind of DBMS, database management system, like MySQL, Sybase, or Oracle, or Sybase is not around anymore. We can use these for visualizations and object-oriented services and so on and so forth. Exist in local client server systems. It can exist in web environments. It can exist in standalone desktop environments. If you're using a pre-existing software library, then chances are you are working with an API. So what are the benefits? We're talking about a three-tiered client-server architecture. What are the benefits of a three-tiered client-server architecture? Okay, and probably the best one is the fact that applications can be partitioned to fit organizational computing needs. So think about it, in a traditional two-tiered client-server architecture, the application sits on the client and does data analysis, requests information such as customer data from a database server. In a three-tiered application, in a three-tiered environment, the application is moved onto the application server, which means it's more powerful, faster response times to users. What else? Easier customization and easier maintenance. So the three-tiered client-server environment is exponentially more efficient, easier to customize, easier to maintain, and probably cheaper in the long run as well. We also need to talk about infrastructure. Now, infrastructure is kind of where I worked for many years. I worked between the infrastructure technology world and the business technology world, and then I crossed the bridge and I represented the business technology world back to the infrastructure world, whilst also talking to the business per se. So when we talk about infrastructure, we're talking about hardware, we're talking about software, not application software, but kind of software for our hardware, I guess. Data, facilities, human resources, and services that support the decision-making, business process, and competitive strategy. It's the least sexy part of technology, right? But it's absolutely the foundation on which everything else sits. Okay, very, very important to have a robust information systems infrastructure environment. So what you typically see is more and more these days that organizations are not going to go and buy and have their own infrastructure environment. They'll actually go and buy and rent them from elsewhere. We can talk about this very shortly even, when we talk about cloud computing. So the thing about managing an infrastructure environment is it can be increasingly exponentially challenging to maintain, right? It can be really, really demanding. You're going to get a lot of growth year in, year out. And as a result of that growth, it's being seen in all over different places. Your kind of infrastructure can get this kind of sense of being fragmented, okay? And there's been a recent change in the fact that the growth and maintenance of infrastructure services is quite complex and challenging. So it kind of, instead of thinking about infrastructure from a development and maintenance perspective, people or organizations are now beginning to think about infrastructure by looking at the services that it provides. In this context, and one of the things I want to talk about, which you need to know about, which you will have access, understanding to, is cloud computing. Okay, so what does it say? Provision of applications over the internet where customers don't have to invest in the hardware and software resources needed to run and maintain the applications, but instead somebody else provides them and you get charged on a per use basis. So AWS, S3, EC2, these are all examples of cloud computing, which you probably have access to. I use AWS all the time. So it follows this kind of utility model, this utility computing model, providing the services to the companies. So it's on-demand computing where the resources, whatever it is you're trying to do, processing, data storage, networking, are rented as needed. Now, there are several characteristics of cloud computing that you need to be aware of. Let's look at those in turn. There's 5 of them that we need to know about starting for this class. So first one, on-demand self-service give users the ability to access cloud resources as needed. Okay, so you rock up. It's a bit like going to the buffet, right? If you go to AWS, you've got your credit card. You can help yourself to what you want, and away you go. Okay, so it's on demand. It's self-service. Whatever you want, go and fill your plate up, and you pay for what you eat. The benefit about cloud characteristics is the second one, rapid elasticity. Computing resources can be scaled up and, just as importantly, scaled down as needed, instantaneously and often automatically. So if you look at those two diagrams, the graphs down the bottom, if I have in-house infrastructure, as my demand grows, even before my demand begins growing, I'm going to have excess infrastructure which is not being used. It's a cost. It's not bringing me any benefit anywhere above that blue line. So as we go up, our capacity is there. We're fine. We have sufficient capacity for demand. And then suddenly our demand goes exponentially more than the capacity that our in-house infrastructure can provide. What does that mean? Okay, I'm no longer fit for purpose. I need more infrastructure. To get more infrastructure in-house is going to take you more time than you are going to want to have to get your infrastructure in place to meet your demand. Okay, so it'll take weeks and weeks and weeks. And by that time, you're not being competitive. You're not being able to meet the demand needs. And therefore, you're no longer being fit for purpose. So as your demand keeps on going up, if you're not meeting the demand, then you're not being competitive. Conversely, if your demand drops and you have excess capacity, you have a cost that is not being met by revenue. And therefore, you're not going to be competitive because your costs are too high. That's the challenges of having in-house infrastructure. You look at the graph on the right and you can see that instantaneously your cloud infrastructure can meet your demand from a capacity perspective pretty much in real time, and therefore away you go. So it's much more efficient, it's much more effective, it's much more cost effective, and it's somebody else's problem to make sure that it always works that way. Okay, so you need to have the confidence in your cloud provider that they can meet your needs, but if they can, it can be a very good solution for being competitive. What else does the cloud provide? There's broad network access. You can access the clouds from almost anywhere, from most web-enabled devices. However, you do need to be in communication, right? So if your networks go down, guess what? You're not going to have access to your infrastructure. So I would say a double-edged sword in that context. What else? Resource pooling. Cloud providers offer multiple resources without regard to ownership of those resources. So you can have access to resources and you don't have to worry about it. And then a measured service. You only pay for what you use, okay? So fixed costs associated with infrastructure now become variable costs. So they change per use. If your markets are not very busy, if you're in a financial market in my world, if your market's not very busy and your network usage is down, your costs are going to drop exponentially as well. Okay. There are three different types of cloud computing service models that you've probably heard about. We have infrastructure as a service, platform as a service, and software as a service. So infrastructure as a service, IaaS, you're going to get the basic processing, the storage and network capabilities. So that's the very basic, the foundation of everything. On top of that, you'll get platform as a service. So your customers will be able to run their own applications using tools provided by the service provider. So you'll get an operating system and so on and so forth, web server, DBMS, and so on and so forth. Or you can go for software as a service, where applications, the actual applications themselves, are provided by the service provider, such as Salesforce.com. That's a good example. Let's look at these in a little bit more detail, each of them, starting with IaaS, so infrastructure as a service. So in IaaS, only processing, storage, and network are provided by the cloud computing resource. Gives you that flexibility, gives you all the basics that you need, but you'll note you've still got to pay for your software licenses. That's your responsibility. Quite high setup costs, yeah. And they give an example there. Netflix migrated its own IT infrastructure to AWS. So just remember, so while the infrastructure is provided, the basic infrastructure provided, everything else is the customer's responsibility. Compare that to platform as a service, PaaS. You run your own applications, which are designed using tools provided by the service provider. So you control your applications, but you don't have control over the underlying infrastructure. So if you're going to be on Microsoft Azure or whatever it is, or operating system, you're not going to have control for that. You don't have to worry about software licenses for things like web servers or the database management system, because that's the cloud computing resources responsibility. So the service provider manages the functioning and updating of the platform. You're basically just having to worry about your application environment. And then SaaS, software as a service, you are using applications provided by the cloud infrastructure. You don't have, again, any control over the underlying infrastructure. You only have limited control for configuring your application-specific settings. You don't have to do anything as a customer. It's probably the easiest environment to deploy from a customer's perspective, because you don't have to worry about hardware infrastructure, platform, or software. You're just literally using the services that are provided by the cloud computing resource provider. And there we have some examples like Gmail or Google Docs and so on and so forth. It's useful to mention that there are a couple of ways of looking at clouds. One of the ways we often demarcate them is between public clouds and private clouds. A public cloud is just what it pretty much says, right? It can be used by anyone on a pay-per-use basis. Maybe those applications that need rapid scalability, so you need to be able to exponentially increase or decrease your demand for processing or data storage very quickly. That's going to be one option to go for public cloud. If you don't have the means for the capital resources to build or expand an IT infrastructure, then a public cloud might be the way to go. A private cloud is slightly a different concept. It's not really the opposite of a public cloud. It's a different way of thinking about organizations controlling how different parts of the organization manage their revenues when it comes to infrastructure. Another way of thinking about a private cloud is this thing called an internal cloud. Okay, so there it is. It's helping an organization balance demand and supply of computing resources within a single organization. Okay, so an organization out of a department that will provide the cloud to all other parts of the organization. So it allows you to control access on a departmental or functional area, so that you can have this. It's almost like funny money, right? So if I'm in department A and I'm renting space off an internal cloud, I'm not actually paying an external organization access to the cloud. I'm still paying my own organization for access to my infrastructure. I'm just using it from a cloud perspective. So I get the benefits of using a cloud, and it's controlled within my organization. Okay, so we used to see this all the time in Bank of America and at Merrill Lynch in the financial world. It just allows you to have a better understanding and management, senior management, to see which areas are using what cloud resources, and being able to control that most effectively as well. So everything's owned by the client. It's centralized control, it's very secure, it's very private. You're not letting anybody else outside of the organization have access to a private cloud. But there are challenges with managing the cloud. It's not the be-all and end-all. It's not just always a happy story, right? There are many issues with the cloud, and some of these are fundamental ones, to the extent that organizations often make the decision not to utilize a cloud offering. I'll put my teeth back in, okay? The first thing to think about is, what are you going to place on the cloud? Do you know, let's take this back a notch. Do we know straight away that just because you're using a cloud service provider, all right, we don't know, A, who else is using that cloud service provider. Your competition may also, and probably are, using the same cloud service provider. So if you suddenly start putting proprietary data, the most important information that is most personal, secure, secret, call it what you will, on a cloud environment, can you have the absolute certainty that you would have if you retain that data inside your organization that is not going to be compromised? And I would suggest you probably can't. You simply don't know who is going to be able to have access to the data behind the scenes. You don't know. You don't know what's going on away from what you see in the cloud and the parts that you're being given access to. Okay, so you have to be very, very careful. So the thing to think about is, okay, when you are thinking about a cloud computing provider, it would be very often the case that no one single provider will give you everything that you want. Okay, you pretty much is going to be guaranteed to partnering with different providers depending on your needs, from an infrastructure, a platform, or a software system provider from a cloud perspective. So what are the issues that you need to think about when choosing cloud service providers? And here they are. Availability and reliability. No cloud service is ever going to be completely immune to errors, network outages, or hardware failures. Okay. First things first, you always need to be in communication with your cloud environment. If you lose that communication, you're dead in the water. Even if you've got that communication, it's not guaranteed that that environment is ever going to be 100% of the time. Okay. Scalability, we go to the cloud because they sell themselves as being able to scale up and down to meet your needs, so that you are not paying for anything that you don't need to use, and at the same time your capacity is meeting your demand. Okay, but is a cloud provider always going to be able to meet your needs every single time? Think about the volatility in the market seen recently in the last month or so. It's just crazy when you've got so many drops and so much rising. The amount of data going across networks in investment banking at the moment in finance is just nuts. If you've got your infrastructure outsourced to a cloud provider and everybody is trying to take advantage of such volatile markets, you can see that there may be limits as to their ability to be scalable. Viability. Viability is an often overlooked component part, but actually is critically important. You want to make sure the service provider will last over time. What does that mean? The service provider has to have a strategic direction and understanding of their strategy that's going to allow them to be in place, providing the services that they need to give to you in 3 years' time, in 5 years' time. You don't want to have a relationship with someone that is not looking forward, is not forecasting to the needs of their clients for the future. So viability is very, very important. I've been at meetings before where we've had people come in and present. I can't remember if I told you this. In New York, I went to a meeting, and this was not for clouds. This was for a high availability software where you can fail over hardware disks for server environments. And I remember it vividly. We had about 6 or 7 offerings, and one was standout, absolutely brilliant. Uh, Absolutely what we needed, and we didn't go with it because we didn't think that the organization that came up with it was going to be viable in the medium to long term. So we went with the second best because the product wasn't as good, but we had greater confidence that the organization itself had a better idea about what it was and where it needed to go. The next thing to think about, security, privacy, and compliance. Now, this is actually a really big issue, and I'll tell you why. Okay, so when you control your own infrastructure within the organization, you know the extent to which you are compliant, okay, with industry regulations, Sarbanes-Oxley or HIPAA, whatever it is. Are you able, to the same level of confidence, to make that same determination when you're not getting access to all the moving parts behind the scenes for the service that you're being given access to, right? So if you're going for, even if you're going for an IaaS, right, an infrastructure as a service, are you going to have access to all the different underlying moving parts? And are you going to be able to guarantee that all those parts are going to be regulated to the extent they need to be for your industry? And the answer is simply no, you're not. No organization in a cloud service provider world is going to give you access to absolutely everything, right? You're going to get access to what you need, what you're paying for, but there are going to be things out of sight, out of vision, that you're not going to be able to determine. If you don't know whether these are regulated to the level that they need to be, then there's a risk there. Because I tell you now, ladies and gents, when there's a problem, and if people come down, if the regulators come down and they find that your cloud service provider is not regulated to the extent they need to be, and that means that you're not regulated, guess what? All right, you are going to get fined. If you get fined and it gets in the press, guess what? Your reputation is going to get a hit. So it's something to think about. What else? Diversity of offerings. What offerings can a service provider now compared to what we think they'll need to be able to offer in the future? How well are they forecasting these needs? How confident are you that they will be able to meet your needs in the future? Openness. How interoperable is the service? And then cost. How will cloud cost compare to an internal cloud, a public, or a private? So cloud service providers, it's very interesting. I mean, it's a good discussion, things you need to think about. Um, um, I guess it's kind of inherent to your generation. You kind of live with cloud service providers. You have an inherent understanding, I think. I can remember back in the day when I first got back into technology back in the early 90s, almost 30 years ago, and this just didn't have this kind of environment, just didn't exist. And when it came along, people were so untrusting of it. But now, obviously, it's kind of like the de rigueur for providing that foundation, that kind of infrastructure environment for organizations.